8.3 continued here. We're factoring this last one in our last video, and I was just checking 13 and 14. Neither of those will go into 216. 15 doesn't either, 16 doesn't, and 17 doesn't, and so we're completely finished. So we are now needing to look for the ones that equal a sum of 58. So we have 54 and 4, which sum to 58. So we are going to rewrite this as 24x squared, and then minus 4x and minus 54. Don't worry about which order they're in, 54x or first and then the 4x or vice versa. The only thing that you need to worry about is that the signs are going to be correct and that the sum is indeed 58. Now from here we can factor out a GCF of 4x, and that's going to leave us with a 6x minus 1. And then from these we're going to take out a 9, and we're going to take out a negative 9 because I need a positive and then a negative. So negative 9 comes out of 54 and leaves a positive 6x. And 9 comes out of positive 9 and leaves a negative 1. And now from this term here and from this term here, I'm going to factor out the GCF, which is a 6x minus 1. And that's going to leave me with a binomial, and that's a 4x minus 9. And then from there I can check and see if I have my answer. 6 times 4 is 24, negative 54, negative 4, so that's a negative 58, and then negative 1 times positive 9, which is a positive, or negative 9, which is a positive 9. And so we do indeed have the correct answer. Now with that last problem, you can kind of see one of the issues, right? Sometimes that multiplying and making a product is more pain in the derriere than it's worth. So let's try this process again. 12 times 5. And 12 times 5 gives me 60. Now 60 is not quite as bad as 216, right? So we have hope here. 1 times 60, 2 times 30, 3 times 10, 4 times 15, 5 times 12, 6 times 10, and you see it is kind of going on, right? So this is one of the reasons why this isn't always the best strategy. 7 doesn't go into it, 8 doesn't go into it, and 9, no, and then 10, we've met ourselves in the middle, so we're done. So now we're looking for those that give this a sum of 17. So 12 and 5, those are going to sum to 17. So we're going to rewrite this as 12x squared plus 12x plus 5x, and then plus 5. And then we have to factor by grouping. So we'll take the first two and we'll factor, and we'll take the second two and factor. So 12 comes out of the first two and an x, leaving an x plus 1. And then out of the second two, I can take a positive 5, leaving me with an x plus 1. And then finally, I'll be able to take the x plus 1, and that binomial comes out, and that's going to leave me with another binomial with the sum in the middle, and the first term is going to be a 12x, and the second term is going to be a 5. And this should be my answer. We can check it. X times 12x is 12x squared, 5x on the outside, 12x in the middle, 12x plus 5x is 17x, and then 1 times 5 is 5. Excellent. We've got it. All right, now moving on to the next one. Again, we're going to do the same process, 2 times 10, and this is going to give us 20, and then we have to have the factors of 20, 1 and 20, 2 and 10, 3, no, 4, yes, and 5, and that's going to be it because they're right in the middle. Now we're going to rewrite 17 as a sum of these factors. Well, there are no other factors, right? None of these sum to 17, and so that means that this one is going to be prime. So this one is exactly a prime, and these can be prime as well. Remember, there's no guarantee they're going to work out and have a factorization other than 1 in themselves, and that's what prime means. So I'm going to write here none sum to 17, and that's why we know it's prime. All right, that does it for this video.